stool.
Hi, good morning all. I welcome you all to join us for this exciting session this morning. You all must have been a part of mathematical sums and equations in your life during school or college. You might have also solved mathematical riddles. But have you ever played with mathematical toys? Seems interesting, right? So today's session is all about toys and exploring them. And the person who would be with us is the great Mr. VS Sastry, who is a maths and science communicator, and he has employed different mediums to communicate these subjects like cartoons, sketching, modeling, puppetry, and toys. And he's also very amazing at origami. He has conducted over 850 workshops in maths origami, in which he also holds a Limca Book of Records in 2012. Today, he is bringing his unique efforts of building mathematical toys in public for the first time. So let's welcome him and know what these toys are about and have some fun this Sunday. Good morning, Mr. V.S. Shastri. I welcome you to the session. Good day. Are you excited for the session?
Surely, reaching out, to the people, to the children, is quite exciting.
Yeah. So the floor is all yours. So we'll just sit back and enjoy and play with your toys.
Yeah. Hello, good morning, everybody. I am VSS Sastry. I live in Kolar, Karnataka. That is near Bangalore. So you must have heard about science toys. In fact, there are great pioneers, in India, like Aravind Gupta. So who have done, lots and lots of work, on science toys. So you have not heard about, I'm sure, about mathematical toys. So my effort, has been, in this direction. So why mathematical toys? So I found that, children, so do not have, anything to play with as far as, mathematics is concerned. The textbooks, what they study, are quite boring. They do not have a picture. They do not have a poem. They do not have a sketch. They do not have any painting regarding, the mathematics. So in fact, it is so dry that from the chapter to the next chapter, there is no introduction. There is no continuation. So this being the case, what I thought was that I have to introduce, something, which is quite exciting. So as of now, when you go to a store, you will find in the mathematical section, if you ask for, something related to mathematics, they will show you puzzles, puzzles and puzzles and puzzles, everywhere, puzzles. So puzzles are the ones which children also engage with when they get attracted to mathematics. Now the problem is such a dire consequences we are having in our education system in India, that children are not getting attracted to mathematics. So in fact, that has been a kind of a headache for the scientists, for mathematicians, for the elders. In fact, new educational policy, in fact, in the introduction itself, it says that numeracy, that is the word they use. So the kind of a numerical skill, the mathematical skill has to be encouraged. That's the kind of emphasis NEP has. So what I thought was, what is the things, which just bother, which is a headache, for our children. So because of my experience, in the since of 45 years, I have been traveling all over India, conducting workshops on mathematics through origami. So I must have conducted around 850 to 900 workshops, by now. So I listed frequently asked questions by teachers as well as, by the students, and zeroed in on some kind of a hard spots. What is the things, that their mathematics does not attract them? What are the hard spots where they feel bored? They cannot associate with. In fact, we force our children, to mug up the things, and that's how, they remember. Okay, let me start, with this. So I told you how did I go about. My approach to the mathematical toys is simple. At first, I will choose a hotspot. Next, I will toy with the toy. It can be related, to that particular hotspot. Then, after children, what they do, with the toy, they will be toying it. They'll be playing with it. So after playing, you should convey the questions also arise, in them. They just don't play. They may also ask, how does it happen? Why does it happen? Then it should reveal some kind of a mathematics. This is the portion of mathematics, related to only primary school. So if this is a toy, it should imply, all the kind of a possibilities of mathematics. That's how I designed. So let us go further. You are seeing here a toy. So this is the box. Okay, first of all, I have to tell you that this particular thing, was designed by me, but not manufactured, by me. It so happened that, I exchanged these ideas with some of the scientists, in Indian Institute of Science. So one, Mr. KPJ Reddy, who was the chairman of Dr. H.N. Science Center in Kolar district. So he got interested in this and he approached KSCST. You are seeing the poster here? Yes. See, this is that KSCST, Karnataka State Council for Science and Technology, and also this is Dr. H.N. Science Center. So H.N. Science Center approached Karnataka Science and Technology and they got a funding of about 5 lakhs. And I was asked to design the mathematical toys for them. That's how, these things, happen. This has been created in bamboo. I did not do it, in bamboo. I did it only in the medium which I know. That is cardboard, paper, and also, at the maximum, foam board. Look at this toy. This looks like a box. A beautiful box. Now I will just open it and see what happens. Are you able to see? So I will just, adjust the camera. So now, what you are having here is a kind of a circle, here with 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. It looks like a clock. And also here there is a small box. And here, what you see is the tables. In fact, when you see, it is a two tables. So this is a kind of a toy, as I told you, how to play with it. I'll just show you. I'll open this box. There is a thread here. So I will use this thread to play with. So remember, I have kept, here the multiplication of 2. So I will just, show you how does it function. So remember this table. These 2 ones are 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. With that, what I can do. So I'll start, from this 2, then go to 4, then 6, then 8, then 10, that is 0, again 2, 12, again 14, that is 4, 16, etc. Look, there is a pattern. There is a pentagon here. So let us go for another multiplication table. So let us go for 3. This is the 3 multiplication table. 3 ones are 3, 3 twos are 6, next 9, 12, 15, 18, 21, 24, 27, and 30. So let us start. So 3 ones are 3, 3 twos are 6, 3 threes are 9, then it is 12, then it is 15, then it is 18, then it is 21, then it is 24, then it is 27, then it is 30. So look at the pattern, what we have. This is the pattern for 3 multiplication. So let us take, 4. This is the multiplication for 4. So let us take it out. So this is 4 ones are 4, 4 twos are 8, 4 threes are 12, next 16, 20, 24, 28, 32, 36, and 40. So let us start from 4. So then it is 8, it is 12, it is 16, then it is 20, then it is 24. So we have come back. So 28. So it repeats. Look at the pattern, what we get. So like this, for each multiplication table, we are having a pattern. So what I'm asking you, to see is, how it can be played with as a toy. So here we have obtained number of, this one, these tables. This is the 6 table. This is a 7 table. So like this, we are having, lots and lots of tables, here. You can go on, having a pattern, here. So children actually enjoy, this. So what is the play here? What is the toy? What is the play here? Taking a thread. So following, this pattern, of the numbers, here, and you will get a geometrical pattern. So this is a mathematical toy. So what is the takeaway? What is the learning? So learning aspect is that, children need not, mug up the things. They just, go on playing, with this, and these patterns, will be associated with each multiplication table. So each multiplication table, has a pattern. So naturally, this kind of an association of a pattern and also a kind of a design, what you get, here, it will stay in their head. So that's how, this toy, works. So please tell me, is it not, good? Is it not, worth, of a toy? So look at the approach. I draw, your attention to my approach. I started with a hard spot. Multiplication tables are boring. So that hard spot I took. Then associated with this kind of a toying. A toy is an activity associated with kind of a toy activity. So people do that toy. They enjoy, this kind of activity. So after that enjoyment, the question naturally arises. What is the pattern associated with a single thing, single multiplication table? So this is the mathematical takeaway. So this is a mathematical toy. Did you enjoy it? In fact, you need not do it, in bamboo. In fact, what I did was in a cardboard. So you can also try that and develop some kind of a pattern, more patterns like this. So after this, let us go. Let us take it away. Let us go for another toy. So this is a beautiful box. It contains 4 pieces. One is equal to sign. On the back of it, there is a multiplication sign. So there are 2 pieces like this. On the back of it, multiplication. On the back of it, equal to sign. There are 2. This one is -1. Back of it is +1. This one is also -1. Back of it +1. This one is also -1. Back of it is +1. In fact, you all know about the multiplication of the symbols like this. You know very well that -1 into -1 is equal to +1. And also -1 into +1 is -1. And +1 into -1 is -1. And +1 into +1 equal to +1. In fact, these kind of symbols, multiplications, it is just, asked, to get mugged up. In fact, till MSc level, as far as I know, there is no kind of a proof being given. We just assume this and then, go about. In fact, children find it, very difficult that +1, -1, that this, etc. In fact, the question asked is, plus 1 into plus 1 equal to plus 1, then why not, minus 1 into minus 1 is equal to minus 1? That is different. So I designed, I identified first this hard spot, and then, designed, some kind of a toy. Of course, this has been made, in bamboo. I did not do that, in bamboo. I will show you the original toy, what I did. This is the toy, I did. This is minus 1. Minus 1 into minus 1. Minus 1 is equal to plus 1. This is the thing, I did. But see, are you able to see? So minus 1 into minus 1 is equal to plus 1. This is what, I did. So here, this is the Billy Chuha kind of a puzzle. Okay, these are the two cats with displaying, into sign and as well as equal sign. And these are the rats, minus 1. This is another minus 1 is equal to plus 1. I showed you, the formula of multiplication of signs. Now the rules of this play, this toy, is very simple. So these are the symbols, these are the values. So exchange, any two. Always you have to exchange 2. So let us see. So this symbol, we take it there, put it here and put it here. Remember the rules, I showed you. So it just shows you that plus 1 into minus 1 equal to minus 1. So mathematically it is correct. So let us say I exchange, this. Put it here, put it here. Then what happens? Minus 1 is equal to minus 1 is equal to plus 1. That is also mathematically true. So let us say I will just, make it ulta. This also I will make it ulta. Then what happens? Minus 1 into plus 1 equal to minus 1. Again, mathematically correct. So let us make this, ulta. So I am at any time I make, only 2. So what happens now? Minus 1 into minus 1 is equal to plus 1. That is also mathematically correct. So how about, making this, ulta? This one and this one. Even then, plus 1 into minus 1 equal to minus 1. Even then it is correct. So what is the kind of a play here? What is the kind of a play, we are doing with the toy? Any two. These are the symbols. These are the symbols. These are the values. Any two, either you can exchange or you can make it ulta. Mathematically, it will be correct. So now, so let us say this also, we exchange like this. Even then it is correct. Minus 1 into minus 1 equal to plus 1. So let us make it in a ulta like this. Yeah. Minus 1 into plus 1 equal to minus 1. So this Billy, this cat can be exchanged. And values, this Chuha can also be exchanged. In any way, you can exchange. But only thing is, always you have to do it in a pair. Joda, that's what, we say. So this is the toy, I made. But they could not do this Billy Chuha. So in bamboo, they just, made, like this. So I'm asking you, to think about this problem. What was my method? My method was identifying the hotspot, then converting it into a toy. So I chose, this Tom and Jerry type, Billy and Chuha, so that it will be interesting, to the children. So this particular toy need not be, played only by the higher ups, where they know about minus 1 or plus 1. For the lower classes, this becomes a kind of a Billy and Chuha problem. Exchanging here, exchanging there, they just play. Then when the question arises, they will zero in on the mathematical fact. So there are three stages. Identify the hard spot, then connect it with some kind of an activity like play with a toy, and then when you extract the fact after playing with it, that it reveals a mathematical fact. So how did you feel about this toy? Did you know that this can be done, like this? That's the beauty of a mathematical toy. So let us go further. This is a fish. You are able to see? Kansata? This is a fish. So what happens is that, yes, lower it, yeah. So this fish opens its mouth, like this. It just opens like this, opens up, opens up, opens up, opens up, then opens up. Again it opens, again it opens. So when it is 180 degrees flat, it just comes out. So let us do it again. So here the question is this. The fish opens its mouth. The fish opens its mouth. It is acute angle. This is also an acute angle. This is the right angle. This is obtuse angle. Again, obtuse angle. This is the straight angle. This is the straight angle. See how many angles the fish shows? Again, let us come back. This is the right angle, acute angle. So it is 0. So this is the toy. So this is the toy, a fish toy. It shows about acute angle, right angle, straight angle, and obtuse angle. So how many angles will be known for the children? So again the angle, knowing the angles and their names was difficult for the children. That's why I designed the opening of the mouth of this toy, a fish toy. So let us go for another one. This is a nice box. So it contains some dice. Lower that. Yeah. These are the dice. You must have seen in a Mahabharata war. So it is done like this and it is played. It is like this. But it contains numbers. So 6,494. Then 3,656. Then 9,919. Then 9,848. These are the 4 numbers. 1, 2, 3, 4. Then what is the total? I'll just tell you the total. In fact, the total is 29,917. How did I do it? Okay, let us try another time. Now I will just write down. I will just write down the total. Total is 29,817. This is the total. See, I am able to do it. How? 4,686, 6,733, 9,819, 8,579. It is 29,817. In fact, how did I do it? So what I did was, this is the first, second, the third one. See, there is a relationship here. This is 9, this is 7. So 2, I have taken it out. 2 I have put here. So it becomes 29,817. So let us try another time. Now you can see. So this is 6,364, 3,676, 9,789, 9,958. So the third one, 1, 2, 3. Take 2 from here. That will be 7. Put to 2 here. That is 29,787. In fact, when we do it in calculator, it exactly shows that 29,787. 9 is here. Take away 2 from here. Put 2 here. 29,787. So how did I do it here? So this is based upon decimal system. So it is a kind of a toy which you can just play. Even in Mahabharata serial, the Shakuni, Duryodhana, etc. They play like this and put it like this. And here I have converted into a puzzle, a kind of a play, a kind of a toy. So here also I am just showing you. Take your calculators and see what will be the total. Come to the third. This is 1, 2, third number. Take away 2 from here and put 2 here. So it will be 27,169. So here again, this is based upon, then when the children play with it, in fact 2 people can have the competition, one with a calculator and another straight away telling this. Then how does it function? Why only 3? So the answer lies in the decimal system and also the trick what I have just used. Okay, this is a kind of a toy. So understanding a decimal system is very difficult for the children. So what I thought was I had to devise some kind of a toy. So this is the toy I have just designed. And I am telling you, these things I did not use bamboo. I used only cardboard. But this was made into a bamboo piece because of the assistance of KCST. So let us go to the next toy. So look at this. This is a Venn diagram, called as Venn diagram. The set of natural numbers, is inside the set of W, that is the whole numbers. The set of whole numbers is inside the set of integers. And set of integers, including these two, is inside the set of rational and irrational numbers. The set of rational and irrational numbers plus all these things included is in the set of real numbers. This is a very difficult concept to understand. In fact, when you take numerical examples and show, children are also get confused. So now the thing is this: how to convert this into a toy which they can just remember. So this is the device I have used. I am showing you this because this could not be done in bamboo. So this is how I do it. That's what I am just showing you. What you are seeing here, it is the world. So inside this world is my nation. Is my nation, that is called as India. So inside this India is Karnataka, that is my state. So inside this state I have my district, that is Kolar district, and inside this Kolar district is my home. So my home is inside this Kolar district, and this Kolar district is inside this state, my state. This state is inside my nation, and this nation is inside this world. Now, make it ulta and see what happens. This is the real number set. This is the set of real numbers. So inside this are a set of rationals and irrationals, and inside that is the set of integers, and inside that is the set of whole numbers, and inside that is a set of natural numbers. So look at the relationship. My home, my district, my state, my nation, and my world. Similarly, natural numbers are inside the set of whole numbers. Both put together are inside the set of integers. But all the set put together, the set of integers is inside the set of rationals and irrationals. Both rational and irrational numbers put together are inside the set of real numbers. So it's kind of an action of one inside the other. Is the question, is the toying here, is the play. And what they understand with the relationship of the world, the nation, the state, the district, my home, etc., is a relationship between the sets of real numbers, the rational numbers, the integers, the whole numbers, as well as the natural numbers. So is it not interesting? So again, I am asking you, to think about this, that zero in, on a problem, which is confusing for the children, then how to convert it into a toy. Maybe, here, I have used that analogy, which becomes, very easy, for the children, to understand. So let us go for another toy. So this is a beautiful box. It contains very many things, like this, and each, has got, some kind of a broken image. In fact, when you can just, put, this thing like this, money. There are so many pieces. In fact, this is a kind of a puzzle. In fact, it can be attached, like this. The insects, get, themselves, attached like this, one after the another. So you have to make it into a circle. When you make it into a circle, in fact, it's the kind. No, I may not be having, the time, to do it, but I will show you, what happens, when it made into a circle. So for this program, I have already made it. Yeah. Just focus it. Focus money. No. Yeah. Yeah. Look here. So all these are insects. And here, there is one lizard. In fact, in the toy, these kind of pieces, are given. And they have to arrange, one after the another. Because each piece, has only, half insect. When the half insect is there, they have to go on, arrange it, like this. And also, they have to arrange, this kind of a diameter. What does it look like? It looks like a circle with a diameter. That is correct. In fact, the circle relationship between a circle and a diameter is the thing, that is the mathematical fact. That is a difficult thing, to understand. But here, is the play. Here, is a toy where, you have to arrange, like this. And something else, you have to know. I'll just show you, what it is. So this relationship between the circle as well as, the diameter is a constant. We call it as, pi. So this is the circumference, and this is the diameter. Usually we say it is 22/7. Here, concentrate here, on the toy. Toy. Yeah. When you count the number of insects, it is exactly 22. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22. Exactly there are 22 insects. And in the lizard, how many pieces are there? 1, 2, 3, 4, 5, 6, 7. So these are 22 insects in the circumference. Exactly there are 7 pieces, here. This is the pie. So the play here is to arrange, these insects, 22 insects, together which is, broken down, and which is a kind of a puzzle, to arrange for. And exactly this is also a diameter, is also a puzzle. So it is a lizard. This lizard eats, all these 22 insects. That's how, we say the relationship between the circumference and also the diameter is the pi. Pi is 22 by 7. Why it is 22 by 7? Because if the circumference is 22, then the diameter is exactly, is 7. This is the meaning of a circle being, perfect with a ratio of pi, that is 22 by 7. Again, my approach is entirely simple. People ask me why pi is only, 22 by 7. So the answer is only this. The circle, if the circumference has only is 22 in measure, then its diameter will always be, 7. Of course, in higher mathematics, we say it's only an approximation. But up to MSc level, we use, pi as equal to 22 by 7. So is this not, quite interesting? I'll remove all these kind of things. We shall go for the next try. So this is a fort. So inside this, usually in a fort, as in a king and queen. Okay, we shall see, what happens, now. The fort is here, the king and the queen, and inside this are the king and the queen. One fort, two people inside, the king and as well as the queen. They have, some kind of a property, some kind of a jewel chest. What is the jewel chest, they have? Each have, three jewel chests. Each have three jewel chests. So we started with one fort. Inside that, king and queen were there, two people. They each are having, three jewel chests. So let us remove this jewel chest. One, two, and three. One, two, and three. So remember here, we had one fort, two people inside, king and the queen, each have, three jewel chests. So each jewel chest, contains, how many? Four boxes, four jewel boxes. Each have, 1, 2, 3, 4. Here also, four boxes. So these also have four boxes each. So 4 boxes. Each has 5 jewels inside. So that means to say 1/4, 2 people inside, 3 jewel chests, 4 jewel boxes, and in each 5 jewels. Now the thing is, how many jewels in total? So the answer is 1 into 2 into 3 into 4 into 5. That is the answer. In fact, in mathematics, what we say, that is factorial 5. So 1/4, 2 people, king and queen, 3 jewel chests, each having 4 boxes. In each box, 5 jewels. So it is 1 into 2 into 3 into 4 into 5. In fact, in factorial 5, we say factorial 5 is equal to 5 into 4 into 3 into 2 into 1. So people can play with it. So let us put it back. So in each the jewel chests, 3 jewel chests are there. Let us place back in a king and the queen. So they go into the fourth. Yeah. So this is a toy, an old fourth. It has how it illustrates the factorial 5. In fact, permutations and combinations are a hard nut to crack. In fact, the concept of factorial is also something hard. That's why I designed a toy like this. Look at this toy. This makes sound. In fact, it is sold in Wayanad in the bamboo as a bamboo toy, as a rainmaker toy. But peculiarity is that it has got these windows here, and there are numbers written here. So I have to tell you something about this. Multiplication of fractions is not at all taught. In fact, in our times, in the olden times, it was taught, but now it is not there. So how about multiplication table like this? For example, so 1s are 1/4, 2s are 1/4, 3s are 1/4, 4s are 1/4, 5s are 1/4, etc., etc. So these are the kind of values we have. Similarly, a kind of a half table. Similarly, a kind of a half table like this. So 1s are half, twos are half, 3s are half, 4s are half, 5s are half, etc. Similarly, how about 3/4? This is a 3/4 table. So this is 1/4 table, half table, and also 3/4 table. So this helps a lot in mathematics, especially in fractions. In fact, here when you see these kind of a tables here, you are able to see that 1/4 table. This window has that 1/4 table completely. Each time you turn, this also turns and reveals another mathematical table. So this is a toy which gives an unusual multiplication table of 1/4 half as well as 3/4. So let us go for another time. This is made in bamboo. So it is like this. This is the platform. This is the platform. This is the platform. It has got a groove here and also 4 circles. And we have also got a man like this who just turns this circle. So what he does, it is fixed like this. Arrow banta. Look, see, look. So there is an arrow. He starts from this point. So he starts from this point. So when we move, it also turns. So the circle, he just turns that circle. He rolls that circle. So this is a toy. So the thing is this: when he starts from this point, he just rolls. He rolls. He rolls. Look at this arrow. It exactly it comes over here. And what's the kind of a distance he travels? Let us measure it in terms of circles. See, these are exactly the same circles. 1, this is 2, this is 3, and this is 4. So from here A to this B, this point B is the circumference. When the circle is getting rolled, from starts from here, comes here, it is up to this. So in terms of that kind of a diameter of the circle, this groove itself is the diameter. This is 1 diameter, 2 diameter, 3 diameter, and something here. So let us measure it with another diameter. So we can use one theorem in geometry and find out that this particular portion here is 1, 2, 3, 4, 5, 6, 7. 1/7 of this diameter. That's why we say the circumference is equal to 1 diameter, 2 diameter, 3 diameter, and 1/7 of this diameter. That's why we say it is pi is equal to 3 1/7, which is 22/7. So this is the toy. So this is mechanized, like this. So a toy, it can be just played in the groove. This man, rotates, this toy. So and finds, the circumference, and then this that groove itself is a measure of the circumference, which we measure as 3 diameters and 1/7 of the diameter. So this illustrates why pi is equal to 3 1/7. Did you enjoy this toy? So this is another kind of a toy. Look, what is here. There are 2 giraffes. There are 2 giraffes. One has black spots, another has red spots. There are also numbers here as well as numbers here. Let us see what happens when one giraffe grows like this. Yes, another giraffe also grows. Another giraffe also grows. So again it grows. When it comes down, it also comes down like this. So both the rate of growth of both, let us say rate of growth of both is the same. So this also grows up and also down, up and down, up and down, up and down. The question is only this: the giraffe A, when it grows, it imitates the height of the giraffe B. That is directly proportional. So in mathematics, what we say is the B, the giraffe B, is directly proportional to the height of A. So it can also grow like this, for example, with a constant. So this kind of a difference in height is a C, that constant. It can also grow like this. So it can grow with a constant and also down. It can also grow and also down. So this is called as directly proportional. So directly proportional are something difficult to understand. So when the giraffe lowers and goes up and down, the bee also goes up and down. It is directly proportional. So this illustrates you this toy, particular toy, illustrates you that it directly proportional. So here you see one monkey and also one man. And the man goes up to catch the monkey. And the man goes up to catch the monkey. Monkey is not at the equal height. So when the man goes down, it just moves up. When the man moves up, it
Hi,
just moves
sir, can
down.
you move the sheet of... Sorry to interrupt you, sir. This is a very exciting toy. Can you move it nearer to the camera so our viewers can see it clearly? A bit
Yeah,
more.
yeah. Off money.
Yeah, this is better.
Brightness is
Better.
more. What? How
Okay.
about now?
Thank you.
Is
Yeah,
it
this is
good?
better. Thank you.
Yeah,
Yeah, it's
yeah.
amazing. We are having so much fun.
Yes, yes. Okay, okay. So look now. The man moves down. The monkey moves up. So the monkey either to catch the monkey, the man moves up, but the monkey goes down. So look at the numbers. What we have written. When the man's number is low, the monkey's number is at the high point. So it is now equal. So when it is at the high point, man's high point, it is at the low point. So this is called as inversely proportional. This is not directly proportional. This is inversely proportional. So this is the toy. What is the kind of a toy? Catching the monkey is the action in the toy. So these are the things which I just identify the hard spot, directly proportionality, and inverse proportionality. That's how I do it. Whether the brightness is good, madam? Brightness is okay now.
Yeah, sir.
Okay, I
Yes.
will show you. Okay, right. I
Yes,
will show
yes,
you
the
another
brightness
time.
is fine. Perfect.
Okay, madam. Right. So here, what you are saying, what you are seeing, are the trays. These are all the small trays. Looks like a masala tray. Here is one triangular tray, and here also, this is a small square tray, big square tray, etc. So I will just remove those things and make it ulta. So behind that there is a drawing like this. So it can be arranged. The same thing. It's a kind of a drawing like this. It's a kind of a puzzle. It's a kind of a collage. A man or as a kind of a bear fishing. So again, you see some kind of a geometry is here, and also you can remember something. This kind of a drawing of one square in a small square or one big square here, and opposite that a small square. This is a rectangle, and this is a rectangle. Reminds you of a plus b whole square. So in all the textbooks, there is something. This is a geometrical explanation, given. In fact, this is a square, this is b square, this is ab, as well as this is ab. So let us try, to do something else. So this is a kind of a puzzle I have told you. We can just, play with it, and then let us see what happens. Are you not reminded of Gautam Buddha? The same a plus b whole square, toy, what we have done. See, this can be arranged, like this. So that's how, Gautam Buddha, is designed. So a plus b whole square has the application of Gautama Buddha. So what we have done is the kind of identity a plus b whole square we have converted into a toy like this, and also abstractly it illustrates you a sitting Gautam Buddha. So I have given you some kind of a toys, what I have designed, and I have also shown you that how it is done, in bamboo, courtesy KCST and also Indian Institute of Science people who asked me to design these things and made it, in bamboo. And I have also shown you that, how I approach the problem. Mathematical toys, you don't find it, anywhere in the world. This is a new concept. So from India, let us work on it. I am appealing to the teachers and also to the viewers. So please design, things, like this and give it to the children. So this kind of a new concept of mathematical toys, it should become ideally a folklore. It should be sold, in the weekly Sundays or in the melas, what we have in ample measure in India. So when it goes to that level of kind of a folklore, then teach people, get children get attracted. They find interesting, in mathematics. So unless, we do that, there is no other solution. That is my feeling. So I invite you, the questions, whatever, the audience has.
Thank you so much, sir. These were really exciting toys. Does anybody have any questions so we can put it up? Let's wait for the questions. How long did it take you, sir, to design and think about these toys and get them finally manufactured?
So manufacturing was quite easy, but designing was quite difficult because, because I was experimenting all the kind of a media to go to the children, and find out, what is wrong, with the approach, in mathematics. In fact, I found, their attention deficit was very low. In fact, that is the case. Everybody agrees now with the WhatsApp generation what we have. The attention deficit is very, very low. But the toys are the ones which even today they get, quite attentive at. So why not put, mathematical facts into the toys? That was my first approach. So I began to experiment, with various things, like this, and zeroed in, on the 20, about 20 to 25 concepts. Of course, I can categorically say these are not the only kind of designs that are possible. Obtain number of designs are possible. Only thing is people have to work upon it. That's all. But what I am appealing, to the people, who are just seeing this is that please apply your minds. You are all creative, and the problem, of the children, especially the teachers. Daily, they confront the problem with the children. The problem is with the conceptual clarity. The problem is the mugging up. The problem is with, the associating an image, with the mathematical concept. All these three can be, combined together to design, toys, like this. So what I can do, you people, can do, much better. Let this be the contribution, from India. Okay, let us say the people, let us say Japanese. They are very good, at making toys. If they were to come to know of this, then what is the kind of a wonders, they can just create. Instead of that, let us try to put our heads together. Let us try to do it. This is my appeal.
Okay. Definitely, sir. This should reach everyone in our country, especially the children who need it most. We have some similar questions from many people, Paresh, Vikas, that if you can explain the dice toy, how did you make that? It's the Shakuni dice toy.
I know that is a secret. In fact, I can just show it to you again. But of course, all these toys, are accompanied, with a pamphlet, and how to approach it, how to play, and also what is the secret, behind it. Because the arousal of interest, that is the main kind of a topic. And I am quite happy that people are questioning regarding that. So it is just based upon, I can tell you. Of course, I'm not taking a workshop here. I'm just displaying the things here. So in fact, you choose any kind of a number, and using a decimal system, and add some other kind of a number to it, and then you expand it in a decimal form, and you will come to know of it.
Nice.
Yes, ma'am.
Somebody is asking that what is Vinay Kumar? What is the relationship between maths and science? We treat them as different fields, but how do you feel that both are related?
Maths and
I
science.
want to know what
In
is the
fact,
relationship and science contributes.
okay, I'll tell you, one quotation, from Galileo. Of course, may not be in the same words, as he said. So Galileo said that, the nature, speaks in the language of mathematics. So in fact, mathematics is so fundamental. Every kind of a science. In fact, nowadays, in fact, 21st century is called, the century of biology. So biology also is speaks, in the language of mathematics. So mathematics is so fundamental, and that's why that it pains anybody when we see mathematics becomes becoming so difficult for the children are going away from mathematics. So to attract them here, some kind of a more effort is required, and this kind of a toy, minimum of toy, is one such kind of an effort.
Okay. Some people want to know where they can get these toys, where they can purchase it, or are there any templates that they can use to design them themselves?
In fact,
I
as
think
of now,
everybody is
I have not.
excited to try your.
That's right. That's right. That's right. I understand. I am the only one, to have ventured, into this. I have not explored those possibilities, and I am at it. In the sense, I require, some kind of external support, because I cannot do it, alone. So I have these ideas. If somebody were to there, to explore it, further, I will be quite happy. There is no copyright.
Okay. And Mr. Pareshas, have you published any regarding your work? I think there's one with origami, right?
No, 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 no. Regarding mathematics and origami, that I have published a book published by Vigyan Prasar. Vigyan Prasar also has my another book, Many Approaches to -1 into -1 equal to +1. And in the vernacular language, I have published more than 26 books. And another popular book of mine is that regarding Jantar Mantar. Jantar Mantar is a pop-up book published by the planetarium in Bangalore, and of course VP Vigyan Prasar is also at it to publish it again.
Oh, that's nice. I think that's all with the questions. Thank you so much. I'm sure
Thank
everybody would have enjoyed watching this session. It was so interactive, and I think all these toys are really genius. And I hope they find the right way to reach every nook and corner of the country. Thank you so much for the session.
children.
Everybody gave their time on this Sunday morning. I wish you all the best. We hope you enjoyed this. India Science is doing regular live sessions, interactive sessions on the fun this Sunday doesn't end now. We have another session this evening at 4 p.m., which is also about mathematics and some riddles with it with Professor Manish Jain from IIT. And that's all for today.